Okay, so this is going from standard to vertex form of a quadratic. This is going the other way. So this time you'll be given a function where you have y equals ax squared plus bx plus c, and you need to somehow magically make it look like this. Textbooks traditionally show you to do it using completing the square, which is a method you have already learned in my class. But for this, as we go into word problems, I really want to focus on having something you can just plug in to get to your solutions. So going from standard to vertex, all you're really needing to know for vertex form are A, H, and K. A is the exact same thing as that A. So whatever A is simply A. That should be easy enough. H. This comes from your Algebra 1 axis of symmetry, negative b over 2a. And this b and a are referring to the b and the a here. And then k, whatever you get for h here, you're going to plug that value into the function to find out what k is. So we're going to use that function notation and say that it's f of h. And the h we're talking about is that h right there. Alright, so for example 3 on this page, a, we're looking at the value that's in front of the x squared, your coefficient, your quadratic coefficient, so that is -1. H is defined as negative b over 2a. So negative b over 2a, that gives us a negative, our b here is 10, over 2 times a, which is -1. Negative 10 divided by -2 is a positive 5. Now that we have h, which is 5, we're going to take that and we're going to plug that into the function, because that's how we get k. We take 5 and we substitute it in for every single x in the function. So k is equal to f of 5, which is negative 5 squared plus 10 times 5 minus 16. And when you plug that into your calculator, or if you want to do it by hand, that's fine too, you should get a value of positive 9. So now you have your 3 letters. You have A, which is -1, H, which is 5, and K, which is positive 9. And those are the 3 numbers you need for this. So y is equal to A, so -1, parentheses, x minus h, and h is positive 5, so x minus 5. Don't forget to close your parentheses and put the square on it, and then plus k, so since it's a positive 9, plus 9. And this is the same thing as this, but here this is standard form, and now we've put it in vertex form. And as you've already learned, the nice thing about this is you can look at it and just know your vertex is 5, 9. Thus the name, vertex form. Okay, example 4. Same thing. First, you're given it in standard form. A is A, so A is -3. H is always negative b over 2a. And I may not have room here, so that's a negative 42 over 2 times -3. And when you simplify that, you get a value of -7. Alright, now that I have h as -7, to find out what k is, I have to substitute that value of -7 into the original function. So that's a -3 times -7 squared minus 42 times -7 minus 154. And that gives us a k value of, also -7. Okay, now this one's a little bit trickier. So when you plug in a, because see now we have our values of a right here, draw a little more attention. So a is -3, h is -7, and k is also -7. So as we plug those in though, we need to be careful. So y is equal to -3 times x minus h. But since h is a negative, when you have minus a negative, that's where you end up with a plus there. So so x plus 7 squared, and then k plus k, so plus a negative is the same thing as minus. And these two are now the same function. If you were to graph them, you get the same picture, they have the same vertex, and that is that.